Today we're going to start looking at combinations. So when we first started looking at permutations, I told you that we were going to talk about permutations versus combinations, right? So today we are going to take a look at what a combination is and how you can tell the difference. So quick refresher on permutations, right? Permutations, we said the order matters, or the selections are mutually independent. So either it matters what order you're choosing the different things in, or they have to be totally independent of each other. Like how when you flip a coin, the next time you flip a coin, you still have the same options you did the first time because they don't impact each other. Okay, so that's what a permutation is. Now with a combination, combinations are a little bit different. So in a combination, the order does not matter. Okay, so permutations, the order matters. Combinations, the order does not matter. That is the key difference between the two of them. Okay, also in combinations, repetitions are not allowed. Okay, so like with heads and tails, how you can have heads over and over and over again, you can't have something like that in a combination. Okay, so that is another key difference that helps you spot the difference between them. So order doesn't matter and repetitions are not allowed. Okay, so examples: selecting 3 students to work together on a group project. If you're working in a group together, it doesn't matter if your name comes out of the hat first, second, or third, you're still doing the same thing with the same people. Okay, so the order in which you're chosen does not matter. Okay, dealing a hand of 5 playing cards, right? If you're playing a game with somebody and they hand you 5 cards, the first thing you do is you shuffle it around so that they go in the order you want them to be in, right? So the order in which they're dealt to you does not actually matter. Okay, so that's the difference between a combination and a permutation. Permutations, the order does matter, okay, and repetitions are allowed as long as they're things that don't impact each other. Combinations, the order doesn't matter, and you can't have any repetitions. Okay, this right here, this is the formula for how to find combinations. So like before, I'm going to kind of just reference this for you, but I don't really use this formula much. Okay, as a quick comparison between the two, so the permutation versus the combination formulas, you're going to see that they're very, very similar. The only difference is that combinations have this extra r factorial in the bottom. Okay, and you'll kind of see why as we go through a couple of these. Right? Okay, great. So let's take a look at some examples. So this one, how many ways can a committee of 4 people be selected from 10 people? Okay, so the key word here is a committee. Okay, these problems, they're not going to say to you, how many ways can you choose 4 people if the order doesn't matter? Okay, it's not going to come right out and just spit out into your face whether it's a combination or a permutation. You have to read and interpret. So you have to look at this and say, well, if it's a committee, then it doesn't matter what order you're picked in because committees all work together. Okay, so this is my key that the order doesn't matter. And that's how I know I need a combination. So we're going to start this the same way that we started permutations, right? I'm choosing a committee of 4, so I'm going to have 4 slots that represent my first person, right? My second person, my third person, and my fourth person. Okay, I have 10 people to pick from, so just like before, I have 10 options. Once I choose one of them, I have 9 options. Once I choose one of them, I have 8. Once I choose one of them, I have 7. Okay, so far it's exactly the same as permutations. Okay, but here's where things are going to get different. Okay, remember when we did way back when we looked at tree diagrams, right? And we listed out all those many different ways that you can create some of these, right? Here's our tree diagram. Okay, well, when you look at all these different ways, there are a lot of things that are repeats. Actually, all of these are all repeats because we use all 4 people, right? If we suddenly say that the order doesn't matter, then there is no difference between TRJV versus TRVJ, right? So what we're doing is we're sort of collapsing and we're figuring out, okay, well, how many different ways are there if we get rid of any kind of a repeated set here, okay? So let's think about this really quick. So if we had a set of 4 things, so we have A, B, C, and D, right? So we're choosing a set of 4 people. So Anna, Bob, Charlie, and Davis, they are the 4 that get picked, lucky them. How many different orders are there for those to have been picked in, right? When we were picking these, how many different spots on my tree diagram are going to have these 4 people in some order? Well, we can count that pretty easily. If we're caring about the order, we can think about it like a permutation, right? Where I've got 4, 3, 2, 1 options, or 24 ways total. So for any given set of these 4 people, so for any given set of 4 people of these 10, there are 24 different orders that you can write their names. So this product here, within that, there are 24 copies of the same group of people written in different orders. And for any group of people, that's true. So what I'm going to do is I'm going to take this answer, whatever this answer happens to work out to be, and I'm going to divide it by 4 factorial. Because 4 factorial, that's how many different ways you can order one group of 4 people. Okay, so we're dividing it to figure out, okay, if we divide out how many times these repeats show up, how many unique items will be left? How many unique groups of people will be left? Okay, so I'm going to grab my calculator and throw this in. So I've got 10 times 9 times 8 times 7. And then I'm going to divide that by 4 factorial. When you do this, 2 options for how you're going to divide it in. Either divide it by 4 factorial, or if you're going to multiply it all out, use parentheses and do 4 times 3 times 2 times 1. Oops, not tangent, 1. Okay, or do whatever your number is, so that 50, 40 divided by 4, divided by 3, divided by 2, divided by 1. Okay, so that's what you're going to have to do to get the right answer. Either divide it by the factorial, or put all the multiplications in parentheses when you divide, or divide by each individual number. Okay, so that's what you have to do to get the correct answer when you plug it in your calculator. So this worked out to 50, 40. We divided it by 4 factorial. There are 210 different committees. Okay, so again, think about why, right? The reason why is that there are 5,040 different possible ways that you can write them. But for any particular group of people, there are 24 different ways to reorder them, right? And that's where that 210 comes from. There's 210 distinct groups where they're each written 24 different ways when you count the order. Okay, next one, summer reading program. You have to choose 4 books from a list of 20. Okay, how many different selections are possible? So again, you have to read this and you have to decide for yourself if the order matters. When you do summer reading, does it matter what order you read the books in? No, right? If there's no extra deadlines other than the end of summer, you can read them in whatever order you want. Okay, so I need to select 4 books. So this would be book 1, book 2, book 3, book 4, right? Okay, I have 20 options for my first book, and then 19, and then 18, and then 17. Okay, so I can multiply that all out. I'm going to get an answer for that in just a second. And then just like the last one, for any 4 books that you choose, there are 4 factorial different ways that you could reorder those titles that are accounted for in this big product. So I'm going to divide by 4 factorial to get rid of all of those extra copies. So 20 times 19 times 18 times 17, I'm going to divide that by 4 factorial, and that works out to 4,845. Okay, so that is the number of different things. Okay, and again, the reason why, right, this guy right here is because any 4 things, right, can be ordered 4 factorial ways. Okay, next one. Pizza Place, you're hiring 2 employees out of 6 applicants. How many ways can you do that? You're choosing 2 people. right? So person 1, person 2. You have 6 choices and then 5 choices, right? But for any pair of people that you picked, they're also listed in the other order, right? Johnny and then Charlie is listed, but so is Charlie and Johnny, and that's the same thing. So I'm going to take this answer and I'm going to divide it by 2 factorial. So 6 times 5 is 30. 30 divided by 2 is 15. So there are 15 different ways to do that. Okay, next two, we are revisiting our letter problems. Okay, so remember when we were looking at words and I said it makes a difference if there are repeat letters? Okay, so that's what we're looking at here. So first of all, I'm going to count how many letters I have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like we got 10 letters. Okay, but within that, we've got, let's see, there's 4 S's. There's only 1 A. There are 2 E's. Okay, there's 1, and that's it, right? Those are the only ones that are repeated. Okay, so here's how we're going to do this, right? My 10 letters, I would have 10 slots, and it would be 10, then 9, then 8, right? All the way down to the bottom. So I'm just going to go ahead and shortcut that and say it's 10 factorial. Okay, so there's 10 factorial ways that you can just reorder these letters. But when you look at that, for any particular order, because we have these identical items, right? Think about like if I did this out and I color coded it. So each letter was a different color. Okay, so we have a green S and we have a blue S. So there's one option where the green one is here and then the blue one. But then there'd be another order where it's the blue one and it's the green one, right? But it doesn't make a difference because we're looking at how many different ways, how many different words can you make, right? And whether it's a blue S and a green or a green and then a blue, it spells the same thing, right? So the order in which these 4 S's are placed doesn't matter in terms of where they are compared to each other, whether this S is here or that S is there. It doesn't make a difference. It's still an S. Okay, so what I'm going to do is I'm going to divide by 4 factorial because there are 4 identical S's that can be placed in any order without changing anything. Okay, and then similarly, the E's, I could swap these 2 E's and it would still spell the same thing, right? So for any order of these letters, no matter where those 2 E's are, I could swap them and it would be the same. So I'm going to divide by 2 factorial as well. Okay, so in my calculator, I'm doing 10 factorial divided by, and just as a side note, I kind of recommend that you know some of the smaller factorials without having to type them all in. So like know what like 2, 3, 4, and maybe 5 factorial are, because it's going to save you a little bit of time. So if you just know 4 factorial is 24, you can just divide by 24. And 2 factorial is just, it's 2 times 1. It's 2, right? No need to go through all the trouble of finding the exclamation mark. Okay, so it'll save you a little bit of time if you know just a couple of those smaller ones. All right, so next one, Mississippi. For some reason, Mississippi is a very popular word to look at when you're discussing these kind of things. So I'm going to count up how many letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 letters. Okay, within there are, let's see, 1, 2, 3, 4 I's. Okay, there are 1, 2, 3, 4 S's. There are 2 P's. And I think that's it. Okay, so my total number of ways of ordering these, right? 11, then 10, then 9, then 8, and so on. So we're just going to jump to 11 factorial. And then I'm going to divide by 4 factorial for those I's, another 4 factorial for the S's, and 2 factorial for the P's. Okay, so we're dividing by our repeat letters. So I'm going to do 11 factorial divided by, and again, I know 24 is 4 factorial. So I can just go ahead and plug those in. And it saves me the effort of having to go through my calculator and hit all those extra buttons. And there we go, 34,650. Great. This one's a 2-pager. So let's continue on to the next one. All right, so this one, we got the Astros and Lancers in a playoff. The team that wins 3 out of 5 games wins the championship. Okay, so this is a problem that, like, on the surface, it sounds really difficult. Here's how I kind of think about this, okay? So I'm going to think about this in terms of a word problem like we just did, okay? Where I'm going to consider that these 5 games, anytime the Astros win, I'm going to put a letter A for an Astros victory. And when the Lancers win, I'm going to put L for a Lancers victory. So if the Astros win, right, then we're going to say that we had 3 A's. Okay. And then from there, either the other 2 times the Astros lost, or I'm sorry, the other 2 times the Lancers won, or they just didn't play the game, right? Because when you do a tournament, if you win 3 times in a row, then you stop. So these kind of represent, the A's sort of represent Astros winning, and these represent either the other team winning or the game not being played. Okay, so if then what I'm going to treat this like is I'm going to treat it like it's a word, right? How many different ways can these things be reordered? Well, I have 5 different things, so there are 5 factorial ways they can be ordered. Okay, but then I've got some repeats, right? I have 3 repeated A's and I have 2 repeated L's. Okay, so that's sort of how I think about these. So then I can just throw into my calculator 5 factorial, right? Which again, might be worth knowing that that's, man, I keep hitting the wrong button. Might be worth knowing that that's 120. Okay, if you don't know that, it's a good piece to have handy. So I'm doing 5 factorial divided by 3 factorial is 6, and 2 factorial is 2. So that's just 10. Okay, so that would be strictly if the Astros win. Okay, so then the second question is how many different sequences of games are possible total? Well, the only possible thing that can happen is either the Astros win or they lose, right? So what I'm going to do is I'm going to calculate, well, how many different ways can the Astros win? And how many different ways can the Lancers win? The whole thing, not just one game. And when I add those together, that'll equal the total possible ways that this sequence of games can be run, right? So we already figured out 10 for the Astros winning, right? Well, for the Lancers, it's going to be basically the same thing, right? Except I would think of it as 3 L's where the Lancers win and 2 A's where either the Astros win or the game wasn't played. So I would have 5 factorial divided by 3 factorial, 2 factorial, which is still 10. So that's another 10 games. So in total, there are 20 possible different outcomes. There's no way for there to be a draw. Okay, so that's the idea of combinations. And as you probably are feeling, the difficulty starts ramping up once combinations come into play. For right now, we are going to focus strictly on combinations. We're just going to play around with combinations, but there is going to come a day where we're going to start mixing together, where sometimes it'll be a combination and sometimes it'll be a permutation, and you're going to have to figure out which one it is. And we're even going to do some problems where part of it will be a combination and part will be a permutation. And you have to figure out which parts are which. Okay, so it's really important that you are really examining each problem and thinking to yourself, why is this a combination? Why is it not a permutation? Why did I have to divide by 4 factorial? What about this question means that I need to divide by 4 factorial? Okay, so make sure that you really spend some time thinking about that. Because if you don't, it's going to make this almost impossible for you.